Let's consider the domain name service. It is an internet application which is good to explain how such distributed internet applications are working. What is the problem? It is a technical problem. The problem is that no human can easily remember such type of IP addresses. And these are only the IPv4 addresses. If we have to remember IPv6 addresses, it's much more difficult. What is easy for humans is to remember such names. So www.hpi-web.de or openhpi.de, business.ibm.com, whitehouse.gov. And indeed, this is exactly the idea of the domain name service, that humans, it is allowed for humans to form such type of names, and then by means of the domain name service, these names are translated into the corresponding IP addresses. How this is implemented? The idea is to introduce a hierarchical structured namespace, the domain names. The hierarchical structure comes from the fact that also for the domain names, it needs to be guaranteed that they are uniquely defined worldwide. Here, let's start with an example. This pc55.hpi.uni-potsdam.de is one example of such a domain name. Then the provision of the domain name service in the internet is to translate such domain names into corresponding IP addresses, and to do this automatically, so that the humans only need to work with the domain names, that tell something, and then the system automatically translates it to IP addresses. The Internet Protocol only understands IP addresses. IP protocol does not understand domain name. We will discuss later the domain name service is a distributed application, and like almost all other internet application, it is client server based. Few words about history. This is Paul Mockapetris, who introduced the domain name service in 1983. In the beginning, it was only a table. He actualized, which shows the domain name together with the IP address. But in the moment, internet was increasing a lot. This needs to be a more sophisticated technique behind. The standardization was done of the domain name service in the RFC 882 and more recent in the RFC 1034-35. Let's have a closer look to the DNS, domain name service address space. And let's go back to our example of a computer in our lab, the pc55.hpi.uni-potsdam.de. This last part is called top-level domain. Then, divided by a dot, we have a domain name. Domain name of University Potsdam. Then we can have several subdomain names, domain and subdomain names, and each of these different subdomains are separated by the other part of the domain name by a dot. These dots provide a tree-like structure for this namespace. And exactly this tree-like structure allows to assign responsibilities to different instances, because this domain name service, this translation service of domain names to IP addresses for all the IP addresses is a big task that needs to be done by different partners. Let's make this more clear with the tree structure of the domain name address space. Here we have our top-level domain. Below of the top-level domain, there are several domains. For example, our uni-potsdam domain. But below of the top-level domains, there are many other domains. For example, Unimunich, or the ENIC, or German Post, or others. Then, this is one part. Then, in our example, we had the subdomain HPI. But Uni Potsdam can have the domain, Uni Potsdam can have many subdomains. For example, HPI, the computer science department, the business department, the biology, the chemistry department, and others. And then below of the subdomain, below of HPI, we can have several computers, and we have several computers with an own subdomain name. You see, we can concentrate for this translation service on the different levels of the tree. This is exactly the idea, to insist that the domain name service address space is organized in a tree-like manner. Let's start to look to the top-level domains. The top-level domains are centrally assigned, worldwide centrally assigned by ICANN on behalf of the IANA to internet authorities belonging to the Internet Society. There are different types of such top-level domains. One type are so-called generic domains. The generic domains cite institutions or organizations. For example, .com and the .com top-level domains. This is for commercial enterprises. And the older of you remember the .com area, a time when in the beginning or in the middle and the end of the 19th of last century, many internet companies, internet enterprises become important, and they were characterized by their internet address which ends on .com. Edu is an important top-level domain that's used for educational institutions inside US, that we have with Gov and military US institutions. Depends on the fact that internet was introduced in US. Then we have org for non-profit organization, international for international organization and network. These are the generic domains. Besides of the generic domains, we have also so-called country domains. Country codes according to the ISO 3166. So, for example, .de, the top-level domain for Germany, France, UK, Russia, Switzerland. This is interesting. This Tuvalu is a small, wonderful island in the South Pacific. And it is famous because broadcast companies, TV companies, they like to have this top-level domain TV, and people from this island make a business out of it. Very recent, we have many other additional top-level domains are introduced. For example, like .books, .singles, or .berlin. The reason is that many companies, many cities, many institutions want to cite more directly on their business by means of the top-level domain. For the administration of the top-level domains, there are associated companies responsible. So, for example, in Germany, that is the ENIC. That's the Deutsches Network Informationszentrum. They are sitting in Frankfurt, and they are responsible for the top-level domain .de. What does it mean, this responsibility? This responsibility means that if anyone wants to introduce a domain name .de, then he has to ask the ENIC, is this domain name available? And then the ENIC makes decision, yes or no. And in case of yes, and if the person is paying, then the ENIC registers this new domain name. If another company later asked for this domain, then the ENIC find out it is already registered, and in this way it's guaranteed that there are no different domain names or no multiple use of existing domain names. Now the domain name service has to provide the translation of this domain name into the IP address. And this is done in the following way. The user enters the domain name of a resource he wants to see, of any kind of internet service. Then the user client, more exactly the DNS client, also called resolver, submits a name query to the domain name service. Then the name service processes the name query and assigns to the domain name the right IP address. And this combination is returned to the user client, to the resolver. Then the domain name information is managed by the domain name server in form of resource records. We will later have a closer look to this. Then the client now can use the IP address which it receives from the domain name service for requesting the application he wants to request. And then the address server processes the query. For example, if it's an HTTP server, he requests the HTTP request and sends back the HTTP document to the user. And a user now can use the resources. So this part here, this is need to be done for every application as long as the human user works with domain names instead of IP addresses. So here in the beginning, perhaps you did not become aware of this process because all is done in the back. The user does not see it. It's an interaction between the DNS client and the DNS server that sends back the IP address, and then the user request for the domain name is automatically translated and is requested with the corresponding IP address. Now the question how this domain name service is performed. Does it make sense, like in the beginning of the internet time, to have a central server that manages all the IP requests and the associated domain name servers? Here is in picture. We have the central DNS server, and each of the hosts in the internet who wants to request an internet application needs, and does only know the domain name, needs to get an information from the central domain name server telling the corresponding IP address. So you see, due to the problem that we have more than 1 billion internet hosts, such a central situation, such a central domain name server would be permanently overloaded, though that's not the right way to implement domain name servers. For the way the domain namespace is constructed, this hierarchical division into non-overlapping zones, this is exactly what can be used for design a more efficient domain name service. The idea is that each of this zone is managed by an own domain name server, and that the domain name service is a distributed service that are run by many different and cooperating domain name server. Each of this domain name server from each zone knows in any case all the servers and hosts on the hierarchical level directly just below it and the server directly above. So the domain name server may know all the others, but this is a must, The domain name server of a SUN needs to know all the servers on the hierarchical level directly just below him, and on the lowest level it needs to know the hosts, and it needs to know the server that's directly above from it. Let's have a closer look by means of an example. Assume there is a host in a research group at the Stanford University who wants to access a page of our website here in HPI, www.hpi.unipotsdam.de. That is a domain name. He knows the domain name and he wants to receive a resource. The local it's a local domain name service client, it's the local DNS client of this research group, does not know the associated IP address, and for that reason the local domain name service client is asking the domain name server of the computer science department of the Stanford University. The local DNS server of the computer science department also does not know the corresponding IP address, so it is asking and forwarding the request to the domain name server of the Stanford University. Also, the Stanford University domain name server does not know the answer, so the request is sent to the domain name service of the top-level domain edu. The top-level domain edu does not know the answer, but analyzing the domain name, it finds out that top level is .de. So the request is forwarded to the domain server of the top level domain DE. Top level domain DE knows whom to ask, and then back to the top level domain server, so the DNS server of the top level domain edu, the answer. And so now the DNS server of the Stanford University knows whom to ask. It has to send the request to the domain name server that's responsible for the UniPotsdam domain. UniPotsdam does not know HPI, so it sends the request to the domain name server of the HPI, and the HPI, of course, it knows the corresponding IP address corresponding to www.hpi.uni-potsdam.de, and now all the way back this information is sent over all the intermediate domain name server back to our local domain name service client, and now the domain name service client can send the request to the of the resources of the web by using, instead of the domain name, the IP address. You see, it's a real complicated interaction, and it shows how the internet is working. Remember, in the beginning we said a central domain name service, it's not practical. It's every time overloaded. But if we see that now one request needs so many interactions, does this not lead to an overload problem? The price that has to be paid for the distribution of the domain name service as different domain name servers is high, because the name resolution can require a cascading amount of domain name service requests. So one needs some idea to drop this situation, to drop this traffic situation. So in the distributed domain name service, some techniques are applied which makes this distributed domain name service much more effective than the centralized one. And the idea that are used are the so-called caching, domain name DNS caching. DNS caching, the idea behind is that the most recently requested IP addresses are stored in an intermediate storage in a cache. So in a cache on the local host in Stanford, there is now the answer, the corresponding IP address to the domain name. It is stored for a while. in the cache. So if next time the local host wants to access the web page of the HPI, it can receive the corresponding IP address directly from its DNS cache. And in the event, and this, it's very usual that if one interaction was taken, then also other interactions are taken with the same website. So in this way, this idea to make use of caches very much help to avoid domain name service requests, cascading domain name service requests, and in this way to low down the needed communication, because at the end the user wants to receive a website and the user wants not to create a lot of traffic, only to find out the corresponding IP address to domain name. The domain name service caching is very effective because the domain names are not so often changing. So the information is static for a while, so the answer that the local host receives from his cache is in most cases valid. The domain name service cache entries remain active for predetermined time, that is the time to live, and then they are deleted and are replaced by new, more fresh entries. To finish our consideration of the domain name service, we have to look how the information are interchanged, the domain name which are needed for performing the domain name service. And this is the so-called domain name service resource records. These are the information that are exchanged between the domain name service clients and the domain name service servers. It's the domain name, it's the time to live information, it is a class, it is a type, and the types, there are different types possible. For example, start of authority, SOA, a host IP, mail exchange, name server, and others. And then, of course, the value of the corresponding IP address.